we are going to see how we can build a simple Java inspector in the OBP using the OBP2 toolkit. So first of all, we create a Java project that will have a dependency with on the OBP2 runtime. And once this is set up, we can start building our small inspector. So the first thing to do is create a plugin that will inherit from e-language plugin, and in our case, we'll have the configuration as the G-inspector configuration. The transitions, the actions will be fields of the objects, and we don't have any payload. We'll put a name for our inspector. It will have an extension, and we have to define a language module function. And in our case, we'll do something very simple. We'll just instantiate our transition relation and a tree project. The transition relation will hard code for now the object that we are going to inspect, and it will be the transition relation itself, the G-inspector transition relation itself. So we put this here in the configuration, and the initial configuration will be a singleton with this configuration that we have just created. To get the fireable transitions, basically we are going to look in the source configuration for the data field and retrieve all the fields defined in this class through this helper method. That basically retrieves all fields that are non-static from the class itself and all the inheritance hierarchy. The definition of the function fire1 transition basically will take the source configuration and the field that we have chosen, and basically we are going to retrieve the object that is stored in this field and create a fire transition from the source towards the new configuration, the field, the object stored in the field, and the action, basically the field itself. We need the configuration class, notably because we have to define an equals function and the hash code functions. And in our case, basically the G-inspector configuration is just a wrapper on the object data, and the equality, we are using the object equality, and the hash is the object's hash. And yeah, and finally the tree projector, it simply creates a tree item based on the object that we have on hand. And here I'm using a simple helper that will descend on the object tree and retrieve some fields. And the transition will show just a field name, column, the class name. In order for the plugin to be detected by the OBP runtime, we have to define in the resources a meta-inf directory with a services directory and a file OBP runtime core e-language plugin that will just indicate which is our plugin class. Now, if we run OBP2, we can see that we have loaded a file with a .g extension, an empty file, because basically our inspector is hard coded to this object, and we now can look at our class. So basically here we have the inspector on a G inspector transition relation, and we can see that through the inheritance of the default transition relation, we get the field module, which stores the language module itself, which itself has a number of fields: the transition relation, which is the self, an atomic proposition evaluator, an atomic proposition provider, a tree projector, a marshaller, and an is accepting predicate. If we follow the module field, we get an inspector on the language module that allows us to follow each of the fields. So for instance, if I go to the transition relation, I'm simply going back to our initial configuration, and that's shown with the colors here. But if I follow, for example, the tree projector, we'll get to our G inspector tree projector class that we have defined, and which itself has a back pointer towards the module. So now if I follow the module instance, I'm going back to the language module. From the language module, we can see that the fields that we have already followed are shown as grayed arrows. And if we follow a field like atomic proposition evaluator that we have not instantiated ourselves, we can see that we are going to get an inspector on the no atomic proposition evaluator, which basically it's linked with our module but doesn't have any particular fields or any behavior. So that's it for the interactive simulation. Now we can do an exploration of our object graph, and we can even check if we have deadlocks in our object graph. Basically, we get to an object which doesn't have fields, and indeed, in our case, we have this situation, because from the transition relation, we can get to the module, and from the module, if we are following the is accepting predicate, which is a lambda expression, we get to an object that doesn't have fields, and we cannot follow it anymore. So thank you for your attention, and see you next time.